Hello guys. Hello. Are we ready for tonight's class? Good evening. Can you hear me? Can you hear me? Can you hear me? Okay, all right. I'm waiting for others. You're still the only one here now. I don't know. Can the other person hear me? The person that's just joined now. Can you hear? Can you hear me? Hello. I will start in the next 2 minutes. Let's try and wait for others. But can you all hear me? Is the video clear? Can we see? Where are the others? So we have 50 more seconds. In the next 50 seconds, I'm going to start. Hello guys. Hello guys. Hello guys. Hello guys. Okay, let's start. Now, let's start with, can you hear me? You can hear me, right? Can you hear me? Can we hear me? Can we hear? Can you hear my voice? Okay, all right. Now, this is the next question now. This is the next question. The next question it says, please, once the video is not clear, just let me know. The question says we are starting from number 17. We've done it up to number 16 in the previous live class. So this is two block of masses 600 gram and 500 gram. Two block of masses 600 gram and 500 gram. Are we together? Sorry. Two block of masses 600 gram and 500 gram. So here we are going to have M1 M1 equals to 600 gram, M2 equals to 500 gram, are moving toward each other, along a straight line, with speed of 100 centimeter per second and speed of 140 centimeter per second. It means that the first mass, which is 600 gram, is the one that is moving with that first speed. That first speed is what? 100 centimeter per second. The other speed is 140 centimeter per second, respectively. So let's say that means our U1 equals to 100 centimeter per second. Our U2 equals to 140 centimeter per second. So the question now says, if the block collide and stick together, now you have to pay attention to this particular question. If the blocks collide and stick together, number one, find their final velocity. Number two, the loss of kinetic energy during the collision. So let's start with the first one, finding the final velocity. If they collide and stick together, I told you in the previous class, they are going to have what? A common velocity, which is what? Unknown. Are we together? So, listen, what you need here is that, see, they are moving towards, you have to pay attention, they are moving towards each other. That number 17, they are moving towards each other, which means they are in opposite direction. They are not in the same direction. One is coming like this, the other one is coming like this. They are facing each other, towards each other. And this is what is going to happen. If this velocity is positive, the other one will be negative. Why will it be negative? Because it's in opposite direction with the other one. Do we understand? So like this one is we are going to have M1 U1 plus M2 U2 equals to M1 plus M2 into V. But our U2 is going to be negative. Why? Because it's in opposite direction with the first one. They are moving towards each other. Do we understand? So here is going to be what? Let's convert this guy to kg. If you convert 600 to kg, divide by 1000, that's 0.6 kg, right? If you convert 500 to kg, divide by 1000, this one is what? 0.5 kg. Now let's convert this one to meter per second. Are we together? So 100 centimeter per second. If we convert it to meter per second, we are going to divide by 100. So dividing it by 100, this is the same thing as what? 1 meter per second. If you divide this by 100, this is the same thing as what? 1.4 meter per second. Are we clear? So this one is going to give us M1 U1, which is what? 0.6 times, what's our U1? Our U1 is 1 meter per second, plus M2 U2, what's our M2? 0.5 kg times, what's our U2? Our U2 is 1.4 meter per second, but in opposite direction. So it's going to have negative sign, 1.4. Are we together? Equals to M1 plus M2, 0.6 plus 0.5, all into V. Do we understand what I'm doing? Is it clear? I need a response. Is that clear? Hello? Okay. So here now we have 0.6 times 1. This one is going to give us what? 0.6. Plus times minus. Plus times minus will be minus. So here we have 0.5 times 1.4. So where's my calculator? 0.5 times 1.4. 0.5 times 1.4. That's 7 over 10, which is 0.7. So this one is going to give us minus 0.7 equals to we have 0.6 plus what? Plus 0.5. That's what? 1.1 V. Are we together? So yeah, if we subtract this, what are we going to get? This one is going to give us negative is 0.1. Am I right? 0.6 minus 0.7 is equal to what? 1.1 V. So at the end of the day, our V is going to give us something like what? Minus 0.1 divided by what? 1.1. So minus 0.1 divided by 1.1 minus 0.1 divided by 1.1. So our V is going to give us what? Negative is 0.0909, which is sent in as negative is 0.091 meter per second. Why do we have negative sign? The negative sign shows that the final velocity, like their common velocity moves in how can I put it now? It moves in should I call it? It moves in opposite direction with that side that have a greater velocity. For instance, if the the two of them, if their resultant velocity is going like this, are we together? If their resultant velocity is going like this, they have two velocity. If their relative velocity is like this, and when they collide, and since the final velocity is negative, it means that the final velocity move in this way. So that's why we get a negative value for this is 0.091 meter per second. Are we together? So it means that the final velocity, the common velocity after impact, after collision, is in opposite direction with their relative velocity before collision. Do we get that? So that's that for that. Now the next aspect we are going to calculate is the loss of kinetic energy. This is where this one is where we have to spend a lot of time. Loss of kinetic energy. Loss of kinetic energy. So let me open another page. Yeah, sorry for. Now, come and see what you are going to do now. So how do we calculate the loss of kinetic energy? I hope we can see the book, right? So I'm sorry, I think it's not showing well. Can we see it clearly? Can we see the book very clearly? Yeah. What do I need to rotate? Please, can we see it clearly? Is it clear now? Let us talk. I'm waiting for our response. Is it clear? Are we not there? Okay, thank you for that. Okay, let me just open another page. Let me open another page so that I can do what I need. Now, here we are asked to find loss in kinetic energy. And don't forget, in the previous class, I told us that loss in kinetic energy equals to total kinetic energy before collision minus total kinetic energy after collision. I hope we still remember the formula. So total kinetic energy before collision minus total kinetic energy after collision. That's the loss in kinetic energy. But we need to find the kinetic energy before collision. The kinetic energy before collision, we have two. Are we together? So we have two bodies, body 1 and body 2. Am I communicating? So for body 1, it's going to give us 1 over 2 m1 u1 square plus for the body 2 1 over 2 m2 u2 square. So this is the kinetic energy of body 1 before collision, kinetic energy of body 2 before collision. Now if we add the two together, it's going to give us total kinetic energy before collision. So this one is going to become 1 over 2. What's our m1? Is 0.6 kg. What's our u1? Our u1 is 1 meter per second square plus 1 over 2. What's our m2? Is 0.5 kg. What's our u2? 1.4. So 1.4. So here we are going to have square. So 1 over 2 times 0.6 times 1, that's 0.3 plus 1 over 2 times 0.5 times 1.4, that's 0.35. So the total kinetic energy before collision is now what? 0. What? 0. Oh, sorry, this is 1.4 square. Sorry, I'm coming. 1.4 square. 1.4 square multiplied by 0.5 divided by 2. So that's 0.49. 0.49. This one is 0.49. So if we add it to this, we are going to get 0.79 joules. This is the total kinetic energy before collision. Now let's find the kinetic energy after collision. Now the kinetic energy after collision is going to give us 1 over 2 m1 plus m2 all into v. Remember the formula in the previous class, right? So at the end of the day here, we are going to get what? 1 over 2. What's our m1? 0.6. What's our m2? 0.5. V square, sorry, this has v square. 1 over 2 m1 plus m2 v square. What's our v? The v we got the other time is minus 0. Let me check. That v we got the other time. Yeah, I'm coming. Let me check. We got minus 0.091. Yeah. So the v is what? Minus 0.91 square. You know, this is negative. If you square it, it will turn to positive. So the kinetic energy after collision is going to give us 1 over 2 into 0.6 plus 0.5. We are going to get, I'm waiting for someone. Guys, going to be 1.1. Then close your bracket. What's minus is 0.091 square? We are going to get minus 0.091 square. So the answer is 0.091 square. So if I put the minus square is still this okay, let me put it in bracket. Minus 0.091, then close bracket, square. You can see that. So the answer is what? 8.28 times 10 raised per minus 3. Are we together? 8.28 times 10 raised per minus 3, which is something like 0.00828. Am I coming? If you multiply it by 1.1 and divide it by 2, 0.00828 times 1.1 times 1.1 divided by 2. So we are going to get 4.55 times 10 raised per minus 3, which is something as what? 0.00455 joule. These are kinetic energy after collision. Now, what will now be lost? The loss in kinetic energy will now give us kinetic energy before collision. This is the kinetic energy before collision. 0.79. Are we there? Minus after collision. Minus kinetic energy after collision. The kinetic energy after collision is that's 0.00455. Are we together? So our loss in kinetic energy will now give us, thank you for that. Will now give us 0.79 minus 0.00455. So our loss in kinetic energy is equal to this. It get 0.785. 0.785 joules. That's the loss in kinetic energy. There is no issue with the, like, it's not hard. It's just a simple question. Loss in kinetic energy is the total kinetic energy before collision minus total kinetic energy after collision. And since you have two bodies, before collision, this is the kinetic energy of the first body, this is the kinetic energy of the second body. Add them together. It's going to give you the total kinetic energy before collision. Now, for after collision, it's just one, but the two mass will represent the mass that you are to use, then V squared. Then you find the one after collision. Then you find before collision minus after collision is going to give you loss in kinetic energy. This is the answer. Is it clear to everyone? Do we get that? Do we get this? Is it clear? This answer? Is it understood? I'm waiting for our response. Is it understood? Hello? Hello, guys. Is that answer understood? I'm not saying anything. Okay, all right, thank you. So let's move to the next question. Let's move to the next question. Now, this is the next question. It's just like the same thing. It's just like the same thing. So I wouldn't waste my time on number 18 because it's similar to number 17, just the same step. You get your answer. It's not hard. If you understand number 17, then there's no problem with number 18. Now let's move to number 19. A ball of mass. Now, some people that are likely to have issue with that number 17 because I use minus for the second velocity. Why is my m1 times m2 times u2? You know, the formula is m1 u1 plus m2 u2 equals to m1 plus m2 into v. Why did I use negative for my u2? Because the question says they are moving towards each other. They are moving in opposite direction. So one will be negative, which is the second one. So that's understood. Now, number 19, you can screenshot this 18 and try it. Now, number 19, a ball of mass 6 kg, the mass of the ball equals to 6 kg. It's a smooth vertical wall, normally with speed of 4 meters per second. Speed, so let's say the velocity is equal to what? 4 centimeter per second. Are we together? And rebounds with the same speed. Let's say this U1, let's call this V. So it rebounds with the same speed, with that same speed, 4 centimeters per second, and rebounds with the same speed. Determine the impulse experienced by the ball. Determine the impulse. If you attend the last life class, we all know that impulse, which is Ft, equals to what? Remember that impulse is something as us change in momentum, mv minus mu, which is something as m into v minus u, right? But here, our u is 4. Our v is also 4. Am I communicating? But our v is in opposite direction with our u, because as the ball hits the vertical wall, it rebounds back. That means as it's coming back, it's in opposite direction with the initial velocity. Am I communicating? V is going to be negative. Do we get that? So our V now is going to be negative. And also, it depends. We can also decide to make our U negative instead of V. Just that one of them can be negative. Like, we can decide to make our U negative. It depends. But actually, in this case, our V is going to be negative. Let me not just convince you, Sha. Our V is going to be negative. So at the end of the day, this is going to give us, what's our mass? 6. If we make our V negative, we will define our answer, but let's keep that aside. Your U is going. As it's going, let me explain better. The ball is moving with a initial velocity. So the ball, so it's moving. This is the initial. Let's consider that one to be positive. So as it touches the wall, it rebounds back. It rebounds with another velocity, but that velocity is the same thing. So this second velocity is going to be negative. Why? Because it's in opposite direction with the first velocity. So our V is going to be what? Negative. Are we together? So here we are going to have impulse is mv minus u. So it's going to be 6. What's our v? Minus. What's our u? You know, it's minus. What's our u also? 4. Are we together? So here we are going to get what? We are going to get something like equals to what? 6 into what? Minus 4 minus 4. That's minus 8. 6 times minus 8. This gives us what? Minus 48. The formula for impulse is what? Newton seconds. Is that question clear? Do we get that question? Is it clear? Hello? Is that question clear? I'm asking us, is it clear? This question, do we understand? Do we understand? Hello? Okay, all right, thank you. Now let's move to the next question. The next question, this is the next question. The next question says, an ice, yeah, that guy said, how do we get minus 4 minus 4? They said, listen, they said a ball was moving with a speed of 4 meters per second. And when the ball hits a wall, it rebounds back with that same speed. It was initially moving with speed of 4 meters per second. It now rebounds back with that same speed. It rebounds back with that same speed. That same speed, 4 meters per second. But that same speed at which it rebounds back is in opposite direction with the initial speed. It's in opposite direction with the initial speed. So that's why we have, since the final velocity is 4, but because it's in opposite direction, it's going to take minus v minus u. Our u is also 4. That's why we have minus 4 minus 4. Is it clear to that guy now? Shadrach, is it clear? Shadrach, if it's not clear, just drop a comment. Now we are moving to the next question. So the next question says, an ice ochre puck of mass 0.1 kg traveling at 20 meters per second. What is the mass? The mass is what? 0.1 kg traveling at 20 meters per second. U equals to what? 20 meters per second. Are we together? Is struck by a stick. Is struck by a stick so as to return it along its original path at 10 meters per second. You know, like it jams something and that thing bounce it back to its original path. That means it moves in opposite direction. So our V here is going to be minus 10 meters per second because it's in opposite direction with the initial. Are we together? So the next one now says, so the question now says, calculate the impulse of the force applied by the hockey. Impulse of the force applied by the hockey. This is it. Calculate the impulse of the force applied by the hockey. What they are still asking us to find is the impulse. Are we together? Not the force. Impulsive force is different from impulse. Here we are not asked to find force of impulse. We are asked to find impulse of the force. So we are still looking for impulse. So here our impulse Ft equals to what? mv minus what? Minus u. Are we together? So what's our m? 0.1 kg. 0.1. What's our v? Minus 10. Because it's in opposite direction. minus, what's our u? Our u is what? 20. Are we together? So we are going to get what? 0.1 times what? Minus 30. Is that clear? 0.1 times minus 30. So at the end of the day, we are going to have negative 0.1 times minus 30. That should give us negative 3. Negative 3 Newton seconds. Do we get that? Is that one also clear? Do we also understand that? Hello, 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 hello. So negative 3 Newton seconds, that's the answer for that one. So now the next, okay, all right, thank you. The next question now is, when taking a penalty kick, the next question says, when taking a penalty kick, a footballer applied a force, that number 21, that's the next question. When taking a penalty kick, a footballer applied a force of 40 Newton for a period of 0.08 seconds. A force of 40 Newton. I'm coming. Yeah, thank you. So a force of what? 60 Newton. Our F equals to 60 Newton. And we are given time with a period of what? 0.08 seconds. So, and the question now continues by saying, if the mass of the ball is 0.085 kg, calculate the speed with which the ball moves off. If the mass of the ball, this time, if the mass of the ball is 0.1, sorry, oh, the first, this is 40 Newton, the question is 40 Newton, mass of 40 Newton, and the time is 0.08 seconds. If the mass of the ball is 0.085 kg, so we have to calculate the speed. Are we together? The speed at which the balls move off. Let's call it velocity, unknown. Is that clear? So, and we all know, listing this question, we are given mass, we are given force, we are given time. We have to find speed. We know that force equals to mass times acceleration. Am I right? Our initial velocity of this ball, our u, equals to what? Is 0. Are we together? Because the ball was at rest before we kick it. Am I communicating? I'm coming. Let me read it. When taking a footballer applied the force for a period of this. If the mass, okay, yeah. So I will know that acceleration equals to v minus u over what? Over time taken. So at the end of the day, we can say force equals to m into what? V minus u over what? Over time taken. So at the end of the day, we can say, what's our F? 40. 40 equals to, what's the mass? 0.085. 0.085 into, what's the velocity? Unknown. That's all we are looking for. Minus 0. So we still have V over what? Time. What's the time? 0.08 seconds. 0.08. So if we cross multiply, we are going to get 40 times 0.08. 40 times 0.08. That's 3.2. So this is going to give us a 3.2 equals to 0.085 V. 3.2 equals to 0.085 V. So that means our V will give us what? 3.2 divided by 0.085. So 3.2 divided by 0.085. So the answer is what? 37.65. So we are going to get so the answer is 37.65 meter per second. 37.65 meter per second. Do we understand this one too? Is this one clear? This question, is it clear? Everyone, do we get that? Hello? Do we get this? Is it clear? Hello guys, is it clear? Is the question clear to us? I'm waiting for a response. Do we get that? Okay, all right, thank you. If you are here to respond, please kindly respond. If it's not clear, let me know. So the next question, okay, all right, thank you. Yeah, the next questions now. The next question is still that same structure of question. Am I communicating? Same structure of question. Same structure. So we will still apply the same thing. So let's not waste much time on that. So now this one now, a machine gun with a mass of 8 kg. A machine gun with a mass of 8 kg fire a 30-gram bullet. Now, a machine gun with a mass of 8 kg fire a 30-gram bullet. So what's the mass of the machine gun? The mass of the machine gun is what? 8 kg. Mass of gun. What is the mass of the bullet that is fire? The mass of the bullet is 30 gram. Are we together? So it fires a mass of bullet 30 gram at speed of 120 meter per second. The bullet move at speed of 120 meter per second. So we are now asked to find the recoil speed of the gun. Recoil speed of the machine gun. So the speed of the gun, you can call it U or G or V rather. Speed of the gun, that's what we are asked to find. Now speed of the bullet. Speed of the bullet. They said the bullet mass 30-gram bullet at a speed of 120. Are we together? So this guy is going to take the formula M1U1 equals to M2U2. This is another formula. Are we together? Of which we derive from the Newton, I think that should be Newton's second law of motion. For every action, there is equal and opposite reaction. An equal but opposite reaction. So what's our M1? Our M1 is the mass of the machine gun, 8 times. What's our U1? The velocity of the recoil speed of the gun. We don't have it. Our M2 is mass of the bullet, but it's in gram. Don't mistakenly use it direct. Convert it to kg. If we divide it by 1000, you are going to get 0.03 kg times what's the velocity of the bullet? The speed of the bullet, 120. So this one is going to give what? 8 ug equals to 8 ug equals to, that is 8 times velocity of the speed of the gun, 0.03 times 120. So the answer is 3.6 equals to 3.6. So the recoil speed of the gun will give us 3.6 divided by 8. 3.6 divided by 8. So the recoil speed of the gun is 0.45 equals to 0.45 meter per second. Is this one also clear? This particular question, is it also clear? Is it also clear? Before we move to the next one, hello, is this one clear? Before we move to the next one, is it clear? Okay. Can we move to the next one now? Now, the next one, number 24, is also a similar question. That a machine gun with mass, you are still going to use M gun, speed of gun equals to M bullet, speed of bullet. Take note of that. Now, let's check number 25. Number 25 says, probably this will be the last, okay, probably second to the last question. Number 25 says, a 0.08 kg bullet, mass of bullet, 0.08 kg. A 0.08 kg bullet traveling at 300 meter per second. The velocity of the bullet equals to 300 meter per second. Are we together? Horizontally strikes a thick vertical wall. It stops after penetrating through the wall. This formula now, I don't think I've proved it. I don't think I've proven it for you before, but you are going to know it now. Vertical wall. It stops after penetrating through the wall a horizontal distance of is 0.3 meter. Distance equals to 0.3 meter. What is the magnitude of the average force the wall exerts on the bullet? Force equals to what? Unknown. Are we together? What is the magnitude of the average force the wall exerts on the bullet? So this one is, let me read again, a 0.08 kg bullet traveling at horizontally strike a T vertical wall. Stops. It stops. You can see, that's what I was looking for. It stops after penetrating. That means V equals to what? 0. Are we together? So we are asked to find the force. So this, whenever you have a mass, is something that is penetrating into a wall and or into a wood or anything, and that thing has a thickness. This is the thickness of the wall or of the wood. Is it wood they mentioned? Yeah, a thick. Am I communicating? So as it penetrates through this thickness, because the thing is somehow thick a little bit, then it stops at the end. Force, the average force the wall exerts on the bullet is equal to m into v minus u over 2l. I think that should be correct. Let me check. Let me confirm if I'm right. F in mv minus u over 2l. Oof. I'm trying to check something. I think that should be right. Coming. Okay, let me just 0.08. Our hem is 0.08. Oh, sorry. Yeah, I've seen what I'm looking for. The average force equals to m. Yeah, it's still the same thing. Let me confirm something. Just we have 0.08 multiplied by 300, then divided by 0.640. I think that should not be 40. Let me confirm what they get here. Well, maybe it's 40. Just give me a few seconds. Number 24. Few seconds, I'm coming. I'm trying to confirm. Okay, not at all. Let me try to remember that formula. I'm trying to remember that formula. So this guy, okay, let's read the question again. The question says a 0.08 kg bullet, 0.08 kg bullet, that's mass, traveling at 300 meters per second, horizontally strikes a thick vertical wall. It stops after penetrating through the wall, a horizontal distance of 0.3 meter. What is the magnitude of the average force the wall exerts on the bullet? Okay, I think I've gotten what I need. Let's do this first. So here we have m equals to 0.08 kg, u equals to 300 meter per second, v equals to 0, f equals to what? Unknown. Sorry. So there's a formula I just mixed together. So sorry about that. So let's continue. This our v equals to 0. Our distance, let's represent it by x. Our distance equals to 0.3 meter. The thickness of the wall it penetrates 0.3 meter. So let's look for acceleration. So using the formula, the third equation of motion, v square equals to u square plus 2as. So we are using our v square is 0. 0 square equals to what? U square 300 square plus 2 multiplied by a. What's the distance? 0.3. So at the end of the day, we are going to bring this one to the other side. It's going to give us 300 square equals to 2 times a times 0.3. We are going to get what? 0.6a. Are we together? It's going to give us 0. So 300 square is what? I think that should be 9, 1, 2, 3, 4. That should be 90,000 equals to 0.6 a. Divide both sides by 0.6. So a is going to give us 90,000 divided by 0.6. So at the end of the day, our acceleration is going to give us 90,000 divided by 0.6. 90,000 divided by 0.6. So acceleration is 150,000. Acceleration is equal to 150,000. Are we together? So the average force. Oh, sorry, this is a particular question. That formula I'm trying to use in the first place, is for a particular question, my bad. I think we still get to the question very soon. I'm trying to make this thing clear. So the average force F equals to MA. F equals to MA. And what's our M? Is 0.08. What's our acceleration? 150,000. So our force is going to give us 0.08 multiplied by 150,000. So 0.08 multiplied by 150,000 times 0.08. So the answer is 12,000. The force now is equal to what? 12,000 Newton. I put naira, sorry, 12,000 Newton. Let me check. Yeah, that's correct. I think I should be right. Yes, 12,000 Newton. Is this clear, please? Do we understand this question? Or I should come again? Do we get, or I should come again? This particular question. Hello? I'm waiting for our response. Do we understand this, or I should repeat it again? Are we there? Hello, are we there? I can see some people are online. Some people are following me, but I need our response. Hello? Oh, you guys have slept? Are we there? Hello? Oh my God. Oh my God. Well, since you are no longer following, because nobody is responding again, and 5 people are still with me here. I don't know why they are not responding. I'm still waiting for our response. If no one responds, probably in the next 3 minutes, I'm likely to stop the live class and just upload the video. Okay. Maybe I'll just upload the video since you are no longer following